Hi, mom and dad out there. Today I'm going to talk to you about the algebra journey um, from grade 2 to high school. In math, some students they find algebra a bit of a challenge. What I want to do is to help you and your children to understand what algebra really is and how you handle it when the children are still very young. Okay, so the first thing that we'll start off is go to Google and get a definition. So the dictionary say the algebra, the part of mathematics in which letters and symbols are used to represent numbers. Yeah, it sounds okay. But probably a more precise definition is it is a kind of math where you use the letters or the symbols to represent the things that are unknown. So the general idea is that you look at a word problem and you find the things that are unknown and you represent them using your letters. Now, once you do that, you'll be able to write the sentences and show the relationships between those things. Okay, now let's recall when we were very young. So when we were little, about grade 2, this is what we often see. All right, here we have a math sentence. This is really simple. So something we don't know, plus with 3 give you 10. So, well, what is it? Now, at year 2, this is what other children do. So they look at it, they sort of say, yeah, it's something I don't know. So I'm going to have a guess. So yeah, I'll make a guess. Suppose the number I don't know is 1. And then 1 plus 3 give you 4. Now, that's not right. It's too small. So you make another guess, right? All right, so the next guess, let's say 5. Now, 5 plus 3 give you 8. That is still too small. So you say, well, 6. 6 plus 3 give you 9. That's very close. So you know, oh, the answer must be 7. So 7 plus 3 give you 10. Now, this is a really, really simple algebra that very young kids do when they are around year 1 and year 2. Now, I'll give you the tip. What I find most effective to prepare the foundation for the kid is when they do the timetable for math. The general habit is that students only learn the timetable forward, but I find it extremely useful to get the student to learn backward as well. So something they don't know, time with 6, for example, will equal 24. So what is it? So by learning this way, they will be able to rapidly do the division inside their mind, as well as they get used to the idea of something unknown. You know, time with something will give you something else. And it becomes very automatic in the mind. This is a really good way to prepare the young kids in year 1, 2, and 3 for algebra. All right, so what happens when we get a little bit older? So around grade 3 and 4, kids start to get exposed to word problem that have unknowns. And that is where the real algebra, start. All right, so let's look at a simple example. Okay, so this is a word problem. there were two monkeys collecting nuts. The older one was greedy. After they collected 36 nuts together, he divided up the nut between them so that he had 10 more than the younger monkey. So how many nuts did the younger monkey get? Now, it actually starts to look a little bit hard. One way very young student from year 2 to year 4 would solve the problem is to use a guess and check. So here we have two monkeys. So we have the younger monkey and you have the older monkey. Okay, and the total. Okay, we know that they collect 36 altogether. So I'll write 36 outside. So I have a bit of a guess. So if I guess that the young monkey get 10, and then the older monkey will get 20, and the total will be 30. Now comparing to 36, it doesn't match, so it failed. Okay, so we increase that a bit. So we go for 12 for the young monkey, and that is 22 for the older monkey. And add together, we get 34. It still failed, but it get very close. So I guess that just one more will do. So 13 for the younger monkey, and 23 for the older, and we get 36. Now we have a match. Okay, let's have a look at another problem. Now on the farm, there are many animals. 1/5 are goats, 1/10 are horses, and half are sheep. The rest are cow, and there are 10 cow. How many animals are there on the farm? All right, for this kind of problem, for year 3 to 4, it will be so difficult. They can either do guess and check, or if they know a lot about fraction, they can try to solve it using fraction at grade 6 to 7 year level. Certainly, at grade 3 and 4, they wouldn't know enough fraction to be able to deal with this problem using fraction. So let's have a look at the idea of guess and check, see whether it's possible. So here we have the goat, we have the horse, and we have the sheep, and we have the cow. So we'll see whether it's possible to do some sort of guess and check. Now we want the total for all of them. Now we know exactly there are 10 cows. So the cow is always 10. Now that become a bit of a problem. So 1/5 is 1/5 there. This is 1/10 there. The sheep is half there. And the rest are cow. Everything is in terms of fraction. Now, honestly, the only way to make sense out of this is to use equivalent fraction. Now, we have 1/10, so the denominator is 10. So we need to get to a common denominator. So 1/5 goes, so equivalent fraction, so that will become 2 out of 10 will be the goat. And half a sheep, so that become 5 out of 10 will be the sheep. And the rest are cow. All right, so what we really need to have is the cow in terms of fraction. So here you have all out of 10. So I have 1 for the goat. No, 1 for the horse, 2 for the goat, and 5 for the sheep. Now you add all that together. You will have 5 plus 2 plus 1 now equal to 8 parts. Now that's all out of 10. So 8 out of 10 will be the will be goats, horses, and sheep. So that means 2 out of 10 will be the cows. There are 10 cows. So 2 part, go to 10 cows. So that means 10 part of animal go to 50. Yep. So the calculation is simply 10 cow divide into 2. You get the size of one part is 5. And then 5 times with the 10 part give you 50 as the answer. So honestly, the guess and check here is not working out. And you need to do the fraction. And this is really difficult for year 3 to year 4 kind of kids to be able to do the year 6 fraction. Okay, so now in Australia at year 4, the student get a chance to do a difficult test to go in to an opportunity class, a gifted class. And this is a question coming from it, and we'll see how a year 4 student may solve it. Now, Jack and Sarah had 12 strawberry. They ate all of them. Now, Sarah ate twice as many strawberry as Jack. How many strawberry did Sarah eat? So you think about it. All the strawberry must be divided into 3 parts. Now, just look at that. Sarah ate twice as many strawberry as Jack. So Sarah get 2 parts and Jack get 1 part. Now, so altogether, we got 3 parts. So 12 divided by 3, you have 4 per part. All right. So how many strawberry did Sarah eat? 2 parts. So 2 times 4 equal to 8. So Sarah ate 8 strawberries. It's not too hard, but the thinking require very basic idea of like fraction. You have to actually divide things up. Now have a look at another one. Now here we have 4 cardboard boxes, P, Q, and R. Box P is 3 kilograms heavier than box Q. Box Q is 5 kilograms lighter than box R. Box S is 4 kilograms lighter than box R. And what is the difference between in weight between the heaviest and the lightest box? Okay, so Q seems to be lighter than others. So we'll see. So we can, from the first statement, it says box P is 3 kilograms heavier than box Q. So we can write Q equal to P minus 3. Okay, now box Q is 5 kilograms lighter than box R. So we can write that. So Q equal to R. Take away 5. Box S is 4 kilo lighter than box R. So we can write S equal to R, take away 4 kilo. Now, obviously, R is the heaviest. So we can write R, to the right. So this is from light to heavy. So the heavy is on the right. Now, if we compare the first 2 statements, so Q equal to P, take away 3, and Q equal to R, take away 5. So we can see that clearly R is the heaviest, so it is on the right-hand side. Now P is heavier than Q, so we have P there, and Q is somewhere here. Now we have to decide where box S will go. Now, if we compare the last two statements, so Q equal to R, take away 5, and S equal to R, take away 4. So S is heavier than Q. So we have S in here. So now we have sorted all of them. So Q is the lightest, and R is the heaviest. So according to the middle statement there, box Q is 5 kilograms lighter than box R. So the answer is 5. The difference between the heaviest and the lightest box. Now, in some country, they use a drawing to help you solve this problem. And this is called the model method. So basically, what they do is they use the blocks to represent your different things. And this is a visual. This is a different way of looking at the problem. And you can see very clearly about the differences between the part, the size of the boxes and things like that. So it will help. Now let's explore, see how this might help to make life so much easier for the young student. Okay, so here is a little problem. There are two numbers. The sum of them is 17 and the difference is 3. So what are they? So there are two numbers. So obviously, one is a smaller number and one is a bigger number. So I'll just say the small number, I'll write S. And I'll get a box for that. So that is the small number. Now, then you have the larger number. And the difference between them is 3. So that means, okay, now I can get a larger box like that. Now, the difference between them is like that. Okay, the difference between them is 3. Now we know that the sum is 17. So if you take all that we plus together, we are going to have 17. Now it's very clear. If you take 3 out of 17, you get 14. And the 14 will account for the 2 equal block there. So that means 14 divided by 2 give you 7. So each of these is 7. Yeah. So what are they? So one is going, so the small one will equal to 7, and the big one, the large one, is going to be equal to 10. So so this is what they mean, the model method. You use drawing to solve the problem. And you can notice that it's very important to pay attention to the smallest item. It's become what they call the unit block. Now, once you figure that one out, you'll be able to use it to figure out all the larger one. And a little older again, around year 5 and 6. Okay, now at this age, let's look at the model method, how it helped to deal with a problem for year 6. Ming had twice as much money as Ryan did. Now, after Ming spent $200, he had $25 less than Ryan. How much money did they have together at first? Now, some students tell me that they read this problem and they think the question is wrong. I mean, how can you work things out when you don't know anything? How much money did they have at first? You're supposed to have the money that belongs to Ming and the money belongs to Ryan, and you need to add them together. But the question doesn't give you anything about how much money each of them have. All you get is a clue. After Ming spent 200, he had 25 less than Ryan. Now, that sounds like a nightmare. Okay. How are we going to solve this? How will a student around grade 5 and 6 can solve this problem? Now, a lot of mom and dad will jump straight into the big gun and pull out algebra and write, equation and use X and Z, X, Y, and Z and all that kind of thing and try to solve it. And that is really at year 8, year 9 level. And student at year 5 and 6 cannot make sense out of it. Now, let's try the model method. Okay, now let's identify who has less money. So Ming had twice as much money as Ryan. That means Ryan has less money. So I'm going to write Ryan. And I'm going to draw a box for Ryan. Okay, so I have the box for Ryan. Now Ming has twice as much money. Now that looks pretty simple. So here we have Ming. And we're going to need a box twice as big. Okay, so now we're going to do a box twice as big. There we are. And now, show the difference between them. So now we have a clear picture. Now, then it's like after Ming spent $200, he has less money than Ryan. And how much less? 25 less. So what it means is he spent and he will have less. So he spent that much, okay? So he spent that much money. And that total money is $200. And after that, he has less money than Ryan. So here, we drew the dot up there. Right. So he have less than Ryan. So that bit here is going to be a 25 here. And the bit here is also 25 there. Okay. So what can we see? Now look at the picture. It's revealed straight away. I change the color. Now straight away that the bit red in here, in red is 25. And we can work out the bit there, looking the parallel line. So what I can see very clearly here is that the bit here is going to be 200 take away 25. So that equals to 175. Yeah. And going back to the idea that Ming have twice as much money as Ryan, and look at the picture, you can see clearly that one of the block there is 175, and Ming have twice of that. And together they have 3 of the block. So the answer is simply 175 times with 3. So that equals to 525. Okay, so 175 times 3 is 525. So that's how much money they have together. Magic. The model method is magical here. It can help a year 5 student draw a few pictures, compare the blocks, and be able to figure out a problem that, many kids would pull their hair out. Now, mom and dad tend to say, oh, yeah, we need algebra. And you're going to, write equations and all that. And we'll go through that at a later time, Now, okay, we have covered the model method. So let's go back to some of the problems we had before and see how we can apply the model method. Now, remember this problem, the way we solved it before was to use guess and check. Okay, so have a look at it. The 2 monkeys. Now, one of the monkey will have less, and that is the younger monkey. So, all right. So here we have the younger monkey, and we'll draw a block for the younger monkey. Now next we have the older monkey. Now the older monkey will have 10 more. Okay. Okay. Now hold on a moment. All right. Now so we'll draw a longer block. Okay. Now you see clearly the difference between the two. So that is going to be 10 nuts there. Okay. Now we know that together we have 36 altogether. So again, it's very clearly, isn't it? So if you take 10 away from 36, you will have two equal blocks there. So that means 36 take away 10, then we get 26. And then 26 divided by 2, we get 13. So each of the things will be 13 here. All right, so the younger monkey will get 13 nuts. Now, you can see clearly that this method is so much better compared to the guess and check. It's quicker, it's very clear. You remember that I proposed before that the best way with the model method is to focus on the smallest item. Okay, now let's have a look at this problem. So on the farm, there are many animals. So 1/5 are goats, so that 1/5, 1/10 are the horses, and half are the sheep, and the rest are cows. Now, if we focus on the smallest item, we would be looking at the horse. So let's think about it. Altogether, we have 10 parts, okay? So we have 10 parts. Now, 1/10 are the horse. So the horse get one part. 1/5 are the goats. So that works out to be 2 out of 10. So the goat got 2 parts. And the sheep actually have 5 out of 10. So it got 10 parts. So if we model this way, we would have the horse take 1 part. So we're going to give the horse 1 part. Now the goat will have 2 parts. So the goat will have 2 parts. And then we have the sheep and then the cow. Okay. Now, so let's give to them. So here we have the goat getting 2 parts. Here we are. Now the sheep will get 5 parts. So we're going to do a bit longer, something like that. And we have 1 part, 2 part, 3 part, and yeah, not perfect, but that's what it is. So the sheep will get 5 part. Now we know we have 10 part. So if you add all together so far 5, and the other 3 give you 8. So that means the cow will get 2 part. So yeah, so the cow will get 2 part. There we are. Now, and then from the information, we have 10 cows. So that means 1 part, a unit block will be just 10 divided by 2. 2 block for the cow, so that equal to 5. So we have the unit block equal to 5. So how many animals are there on the farm? There are 10 parts, and one of the part is 5. So we have 5 times with 10 units, 10 parts. So that equal to 50 animals. Now this looks very clear. And a lot easier than using fraction. Jack and Sarah had 12 strawberries. They ate all of them. Sarah ate twice as many strawberry as Jack. How many strawberry did Sarah eat? All right. So Sarah ate twice as many strawberry as Jack. So because Sarah ate twice as many strawberry as Jack. So Jack is a one who ate less. So we start with Jack. So 1 block for Jack. Now Sarah ate twice as many. So Sarah now is going to be twice as much. Okay. Now, and all together, they have 12. So all together plus everything together, you got 12. So now you got 12 divided into 3 blocks. So that equal to 4, the unit of block. So Sarah ate twice as many. So 2 of the blocks. So 4 times 2 equal to 8. Yeah, we can say that the model method solved the problem really well. And this is very clear. Okay, let's have a look at the next problem. Okay, now this one, as you remember, it was a little bit messy to solve this one before. We need to identify the heaviest box and the lightest box. And it wasn't that easy when we were trying to do that. Okay, so now let's try the model method. Now, box P is 3 kilogram heavier than box Q. So box Q is the smaller one. So we'll start with box Q. Okay. Now, box P is 3 kilogram heavier. So we are going to represent P. Now, P is going to be a bit heavier. Okay. So now, all right. Now, it's going to be a bit longer. Now, we need to indicate the difference between the. So we have P is 3 kilogram heavier. Now, the next thing is a box Q is 5 kilogram lighter than box R. So that means box R is 5 kilogram heavier than box Q. So we will represent R. This is 5 kilogram heavier than box Q. So we're going to draw something a little bit longer again. All right. Now, according to that, we need to indicate the distance. So from here to here, we have 5 here. So R is 5 kilogram heavier than box Q. Now, finally, the final statement. Box S is 4 kilogram lighter than box R. Box S is 5 kilogram lighter than box R. Okay, now, so box S, this is 4 kilo lighter than box R. So box S is going to be roughly like this. Yeah, so that's what it is. And the distance from here to here is going to be 4 kilogram. Now, the picture reveals that the lightest box is Q and the heaviest is R. So yeah, the information is right there. Q is 5 kilogram lighter than box R. So the difference, the weight between the heaviest and the lightest box, the answer is 5. Now, you can say that the model method make the thing a lot easier. Everything appears to be very clear. Now is the time to do a bit of practice. Now, It could be mom and dad, going through this, and later you will show your kids how to do it, or you might be putting your kids straight into the questions. Now, what I suggest is that, just show these questions and get a piece of paper and a pen and do some drawing and have a go and try to find the answer before you see what I do. Okay, let's have a look at this one. Sue has 3 times as much money as Anna. Now, Anna has $200 less than Barry, and Barry has $50 more than Sue. Find the total amount of money that Sue, Anna, and Barry have. Well, obviously, you have to find the different amounts of money, and then you add all of them together. All right. The first thing you need to do is to decide who has the smallest amount of money. So here we have Sue has 3 times as much money as Anna. So Anna seems to have a small amount of money. And then it say Anna has 200 less than Barry. So Anna seems to be having less than everyone else. So we have Anna. Now we get a block for Anna. Now next, we know that Sue has 3 times as much money as Anna. So we're going to have Sue and 3 times as much, so roughly about that much. Okay, now we'll have to indicate that fact. So we draw the line all the way down there. And yeah, that's it. So Sue have 3 times as much. Now, Barry has 50 more than Sue. We don't have to be completely accurate. All we need to do is to indicate that Barry has 50 more than Sue. So we're going to have Barry here. And Barry is going to have more than Sue. So, all right. So we do a little bit bigger. That, and then we also will illustrate that fact. So Barry have 50 more than Sue. Okay, now we have the picture, the model. Now let's see how we are going to solve that. All right, we can see clearly that Anna has $200 less than Barry. So that is going to be the key to solving the problem. Okay, so I'll change the color to red. So here we have from here to here. So Barry have $200 more than Anna. Okay, now from that, we can see the parallel line, and we can see that the bit here, from here to here, is going to be 150 because of that 200 take away 50, so that 150 there. Okay, and what that means is that we can divide 150 by 2, and we get 75 here. Now, we have discovered that the unit block, which is the smallest one, the size of Anna's money, is 75. So put it in, so 75 here and 75 here. All right, So now, yeah, it is quite easy now. Yeah, everything is so clear. So here, we just fill the rest in. So that's 75 here, 75 here, and 75 here. Yeah. So all that. So all we need to do, we find the total amount of money that all of them have. So we count the number of blocks. 1, 2, 3, 4, 5, 6, 7. So we got 7 of the unit block times with 75. And then we plus with 50. Okay, so that is going to be, I'll just do it, 75 times 7. Okay, so 5. So plus 3. So 2 and 525 here. We plus with 50. So that's 575. Yep. So the answer is 575. Okay, we'll have a look at another problem. Jenny and Marvin have 836 stamps together. Jenny has 20% more stamps than Marvin. How many more stamps does Jenny have than Marvin? Okay, the tiny bit of tricky comprehension here with the percentage. Okay, all right. Jenny has more stamps than Marvin. So again, we look at the small item first. So Marvin is going to be the one that we start with. So Marvin. Okay, now we get 1 block for Marvin. And then Jenny is going to be next. Okay, so Jenny had 20% more. Now 20% more work out to be 20 over 100. So that is 1/5. Okay, so think about that. So we got 20% is 20 over 100. So that equal to 1/5. Now that's important. You need to reduce the fraction down to the simplest, and that make it easy. Now, so 1/5, so that suggests that what we should do is to split what Marvin got into 5 parts. So we can say what is 1/5 of it. So here, I'm going to split. So 5 parts there. So 1/5 of it is something that we already see. Now, so Jenny have 25% more stamp than Marvin. So that allow us to draw Jenny. Okay, so Jenny is longer. Okay, now we start to draw the difference. So can you see that Jenny got the 20% extra there? So 1/5 extra. So that is the 1/5 extra relative to Marvin. Okay, so now it's possible for us to see now how many of the blocks are there. So Marvin got 5 and Jenny got 6 altogether. So that means you got 11 unit blocks. Now, all we need to do is we take 836 and we divide by 11. Now, I'll get a calculator to do it, just to speed up the time. Now, so the unit block is 76. Okay, so the question asks how many more stamps does Jenny have more than Marvin? Oh, it's just one of the unit block. So the answer is 76. Okay. Um, I have a few more questions. I'm not going to do them, but you get the idea. So mom and dad can try to work these things out and let your kids go through and work these things out using the same skill. The model method is going to be really helpful to help the young kids around year 3, year 4, up to year 6 to be able to solve these problems without having to resort to the year 8 and year 9, your algebra. So you don't actually have to write all the equations. And some of the really gifted ones at year 4, they can deal with these problems without any issue whatsoever. Once they have been trained using the model method. Okay, so I'll just scroll through to the end, and you see all these are extra problems. So just pause the video and get them solved. In the next video, I will take the same problems and I'll show how you can write the equations to solve them. Now, obviously, for the young student between year 3 to year 6, I do not recommend that you teach them how to write all these complicated equations. Because even if they can do that, they will face with a situation where they have to learn how to solve all these equations. And even if they can do that, you will soon find out that for the same problem, the model method, would be able to crack the problem within 30 seconds to 2 minutes. If you get the student to write all the equations and solve them, it could take 4-5 minutes. And in a competitive exam, like when they go to the selective school test, there is no way that they will have the time to do all that.